Assalamu alaikum, ladies and gentlemen. My name is Mohamed A, Torad, Assistant Professor at Higher Technological Institute in Egypt. I'm the author and presenter of Smart Ambulance using IOT for blood transfer facilities in the first conference on Internet of Things and Embedded Intelligence. The paper outline. The presentation consists of 4 parts: introduction, research methods, results and analysis, and conclusion. $1.35 million people is a death rate as a result for road accident per year around the world. These crashes cost many countries 3% of their gross domestic product every year. Many researchers discuss how to solve the side effect of road accident. This paper discusses how to save injured people from road accident. In normal cases, when an road accident occurred, ambulance transfer injured people to the nearest hospital. But what if the hospital not equipped with injured people needs at that moment? So this paper depends on testing the injured people blood types at the accident location in 30 seconds and enter the blood types and expected quantities in Android application to show for the parametric the best and nearest way to the hospital which have the required blood types and quantities. Every hospital listed at the database has a sorting system which can increase or decrease a certain blood type according to the blood admission or taken from the hospital perspective. The database works as a junction between the ambulance application and the hospital sorting system. At ambulance application, the system can save the injured person's lives by detecting the nearest hospital equipped with the required blood types and quantities. The application uses Firebase and Android tools. Using the Android application, the paramedic will have the authority to create an account to access the database. As shown here in the flowchart, when the paramedic accesses the database using his name, email, and password and enters the blood types and quantities at the corresponding field of the Android application, check the database and list all the proper hospitals which have the required blood types and the quantities and detect their locations with respect to the ambulance current location, which determined using the GPS located at the ambulance. Then selects the nearest hospital location using the best shortest path algorithm, the Gestra algorithm. Then the routing path between the ambulance current location and the predefined target hospital location appear at the Android map. In addition, PIN code is generated to the paramedic that will be used upon arriving at the desired hospital reception to check the blood type and quantity needed and increment them from the database using Android application, which located at the sorting system in the hospital automatically. In addition, increment and decrement process done using QR scanning in the hospital Android application. At the hospital side, the paramedic uses the generated PIN code to acquire the blood type and quantity needed and decrement them from the database automatically. increment and decrement process done using quick response scanning, QR scanning, manually in the hospital Android application. As a results and analysis, the Android application consists of two parts: ambulance Android application and hospital Android application. The ambulance Android application can carry out the following operations, like create a new account, paramedic sign up, paramedic sign in, paramedic request of blood bags and quantities. As the hospital Android application, also many operations can carry out, like increment or decrement of blood quantities with the equivalent types in the database, and checking the quantity available of a certain blood types. Figure show the login page of the ambulance Android application, where the paramedic can choose the option creating a new account for the first time. If the paramedic already has an account, he uses his email or username and password to log in to the database. Figure here shows the paramedic after the paramedic login into the system successfully. The blood request page will appear as shown in this figure. In this figure, the database states all the hospital owing the requested blood types and the quantities to the application with their relative distance from the ambulance. Then the application chooses the best nearest hospital based on Digestra algorithm. On Digestra algorithm using Google Map application programming interface, and the path will be shown on the map with the estimated time to reach to the desired hospital as shown here. Also in this figure, at the hospital, two separate processes are taking place. First one is the PIN code verification as shown figure, and the second is the update of the quantities of each blood type, either by increment or decrement blood bag as the database using the Android application. So a unique quick response page was assigned for each blood type. Conclusion: this work creates a new system which saves accident injured person lives and minimizes the probability of death due to certain blood bag leakage in the hospital by selecting the best nearest hospital with the proper blood types with respect to the accident location. Thank you.